for tonight. Let's just begin.
Okay, I think I can verbalize it all.
Okay.
So, the first one is sketch a graph of a parabola labeling the focus, axis of symmetry, and Directrix.
Directrix?
Yeah, for the given equation.
Okay.
Y equals 12x squared.
All right. The elementary equation is y equal x squared, okay?
Okay.
Which looks like that. What would y equal 12x squared look like relative to this curve here?
It would be up 12?
It's a vertical stretch of 12. And the way you know that is, let's just take this point right here that's 2, 4. Okay?
Okay.
If you're multiplying that by 12, then it's going to be 2, 48. And that point's going to be way up there. So the net effect, the reason it's a vertical stretch and looks like that is because of that. Is because every point that's on the elementary function is 12 times further away from the x-axis.
Okay.
You with me?
Yeah.
Okay. Now, so this curve is 12x squared. What have they taught you at Ralston Valley is the standard format for a parabola, and as a conic section, not as a quadratic, but as a conic section.
X squared equals 4cy.
Okay. Notice that this has an x squared in it. It also has a y to the 1 power, which is the same as what we're used to. In other words, that y equal x squared is a similar format as that. And that matters in the sense that it's going to be a vertical parabola. In other words, parabolas come in multiple flavors. They come in vertical, they come in upside down vertical, they come in sideways, and they come in sideways backwards. When you're talking about conic sections, we have to consider all of those parabolas. Okay?
Okay.
When we're looking at one where the x is being squared and the y is not, that's either vertical or horizontal or upside down vertical. Okay? If you see one where it's x equal y squared, then that's going to be one that looks like that. Hold on one moment. Close my door. And like a vertical one, if this sign is positive, it opens up. If it's negative, it opens down. Well, on a horizontal one, if this sign is positive, it opens to the right. If it's negative, it opens to the left, like that. You with me?
Okay. Yeah.
Okay. So, in other words, when you're talking about parabolas as conic sections, there's all kinds of different things beyond what you learned as quadratics. As a conic section, we also know that there's some focus right there, and there is some directrix right there that is the same distance from the vertex. In other words, however far that focus is from the vertex, that's how far the directrix is also.
Okay.
Okay? So, C is the distance from the vertex, what I have circled here, to the focus. So let's figure out what that is. Let's take your equation and put it into this format. What would it look like? Divide both sides by 12.
So then
That's
y divided by 12?
Well, no. X squared, in other words, if this is your standard format, then you want to make your function look like this. Okay? So it's 1/12 times y. That's what x squared is equal to. Okay? Now, I know that 4c is equal to 1/12. Right?
Right.
Okay. So 4c equals 1/12. Dividing both sides by 4, you get c equals 1/48. And that's how far it is from there to there, is 1/48. And the distance to the directrix, that has to be minus 1/48.
Wait, so then how do you get the 1/48?
Well, if I solve for c, I divide both sides by 4. And 1/12 divided by 4 is 1/48.
So then what happened? Where did the x squared go?
It's still here. In other words, x squared is equal to 1/12 y. Why? Because you told me that y was equal to 12x squared. So if I solve what I have circled here for x squared, I get 1/12 y.
Okay.
You see that?
Yeah.
Okay. Now we have it in exactly the format we need it in.
So then where's the 4? Oh, we divided it. Never mind. I got it.
No, in other words, this is what we want. This is what we have. We can say that 4c has to be equal to 1/12, which is what I've written right there, and that allows us to solve for c. And c is the distance to the focus. It's also the distance from the vertex to the directrix in the opposite direction. So, the focus has coordinates 0, 1/48. What's the axis of symmetry? In other words, what's the line? How do I define that line right there?
Which one?
The axis of symmetry, the line that splits this parabola into two symmetrical parts. I've drawn it as a dotted line, but it's actually the y-axis. How do you define the y-axis? It's x equal 0.
Okay.
Okay. How do you define the directrix?
How far away it is?
Well, we can see it. I've labeled it. It's that dotted line. But how do we define it mathematically? It's, in other words, vertical lines are defined by x equals something. Horizontal lines are defined by y equals something. Well, what is it here?
Y equals 0, negative 148.
If you're talking about the equation of a line, then it's just y equal 1 over negative 1/48. That is the equation of that dotted line. The
Okay.
equation of the y-axis is x equals 0 because everywhere on the y-axis, x is equal to 0. It's just like everywhere on this, no matter what x is, y is equal to minus 1 over 48.
Oh, okay.
Okay, so the secret on all of these problems is going to be, first of all, figure out whether it's a horizontal or vertical parabola, and then try to put it into either that format, or if it's a horizontal format, then it's this format. In other words, where you have y squared and x to the 1 power. If you have that, then you have a horizontal parabola. And we do everything exactly the same. But the very first step is figuring out whether it's vertical or horizontal. So do you have another one? I hope you do.
Yeah.
Okay.
It says, oh wait. No, I don't have another one of these. I have one that's like, sketch a graph. I have to graph the following equation on my calculator, sketch the graph, and then determine the x-intercept, y-intercept, and whether it's a maximum or minimum.
All right. Go ahead and give it to me.
Okay. Y equals negative 2x squared minus 10x minus 5.
What kind of calculator do you have, Sierra?
The Nspire.
Okay. Do you know how to graph functions on them?
Yes, I just graphed this one.
Okay. Now, looking at that function, you can see that it is a parabola that points downwards, right? And it's a vertical parabola because we have y and we have x squared. Do you know how to find, in other words, you're looking at a max, which is the vertex. Do you know how to find the max and also the two places where it crosses the x-axis?
Yeah, the maximum is negative 2.5 comma 7.5. That's the vertex.
Negative 2.5, 7.5?
Yeah.
Which means that when x is minus 2.5, it's right there. And on the y-axis, that comes at 7.5. So that's 2.5 on the x-axis. Oh, excuse me, I got it on the wrong side. Hold on. It's negative 2.5. So it's something like that. So at negative 2.5 is the vertex, and y is equal to 7.5 there. Okay, what are your x-intercepts?
Hold on. Oh.
I have a graphing program on my computer. I don't have the Inspire. I actually have a TI Inspire as a calculator. But in terms of what I can show you, graphs, I use Wolfram Alpha. which is really a terrific program. You put in the function and it gives you the maximum, it gives you the zeros. In other words, it calculates everything that they are asking about. But you need to be able to do it on your calculator just because you're liable to be confronted with that when you take a test.
Okay. I think it's negative 0.5 and then negative 4.5.
Well, let me just check negative 0.5. If I square that, I get a quarter, so I have minus 2 times a quarter, minus 10 times negative a half, minus 5. Let's see if that is 0. It's minus 1/2 plus 5 minus 5. It appears to be that. So oh no, yeah, hold on a moment. Let me put this into Wolfram alpha. Minus 2x squared. Minus 10x.
Minus 5, yeah.
Minus 5?
Yeah.
The other beautiful thing about Wolfram Alpha is it gives you feedback as to exactly what you put in. And sometimes that can be a little tricky, although the Inspire is better than the TI-84 was. But we can see we put the correct thing in. And Wolfram Alpha also gives you the maximum. We can see that it is at minus 2.5, and it does come in at 7.5. It also gives you the zeros, which is a beautiful thing. You don't have to do any trace or anything. The roots are these two numbers here. So the 0, you were rounding it off, but it's minus 5/2 minus square root of 15 over 2. And square root of 15 over 2 minus 5/2. In other words, those are the two zeros. They do come approximately where you said they did, minus 0.5 and minus 4.5. You can see, but that was rounding it off significantly. In fact, when I put in minus 0.5, I did not get 0. I got minus 1/2. So minus 0.5 is not an exact 0. And the other thing that I suspect they want you to do in Algebra 2 is put precise numbers. In other words, don't round stuff off to so many decimal points. Or what are the instructions on this problem? Does it say leave in radical format?
It doesn't say anything. What on my calculator? How do I get the X-Intercepts? If I go to menu and then go to analyze graph.
Once you graph it, you should be able to get the X-Intercepts by one of the menu functions. I can pull out my Inspire if you want and go through it and figure out how to do it and tell you. Would you like me to do that?
Yes, please.
Okay, it may take me a minute to input the function and figure out how to get the X-Intercepts. And now it's going to show me that I don't have any battery power. Plug it in. All right. Do you have the function graphed?
Yeah, I do. I just can't, like, it's on the graph, but I can't tell the exact X-intercept because I can't figure out how to, there's like no option in
Menu, what are your options?
actions, view, graph, entry, edit, window/zoom, trace, analyze, graph, table, geometry, and settings.
Try analyze graph.
I did, and then my only options are 0, minimum, maximum, intersection.
Zero. That's
Okay.
what you want, are the zeros.
Oh, okay. So then, okay.
Got it?
Yeah.
Now, the question is does it give you an answer, anything close to these two answers that Wolfram Alpha gave us? And does it give you in radical format, or does it round it off?
It gives me -5.64 and -4.44.
Okay, well, it doesn't quite look the same as my graph here. This point right there is not -5. That is -4 and change. And this point here is to the left of -0.5, so that would have to be at least -5 and change.
It is. That one, the first one that you pointed to, the first point is -0.56. And then, so the one that you,
okay,
yeah, that one.
-0.56, okay. This one here?
And then that one is -4.44.
Okay, cool. Now, both of those numbers are approximation for the exact numbers.
Okay.
Now, I'm not sure where you're at in class, but usually Algebra 2 is the point where you don't convert numbers to decimals. You leave them in radical format. And whether the Inspire gives you the answer in radical format or whether you can get it in radical format, I'm not sure. But we don't need to know that immediately today. So we got the zeros, we got the line of symmetry. What else did they want to know about this?
The Y-intercept.
Okay, the Y-intercept is very easy to get. First of all, know that what's Y when you're talking the X-intercepts? What's Y equal to when you're asking about X-intercepts?
0.
What is X equal to when you're asking about Y-intercepts?
0.
So plug 0 in for X into this equation, and what do you get? It's really easy to do because every term disappears except the constant.
So -5.
Yeah. And that's always the Y-intercept, is whatever the constant is. Because when you plug in X for 0, this term's always going to go away, this term's always going to go away. And you're going to be left with Y equal -5.
Okay.
Whatever this number is. Okay, so on our graph, I know that this crosses the Y-intercept at 0, -5. Now, did they want to know the focus and all that good stuff also?
No.
Okay, because that would be hard to get, actually. In other words, in order to get the focus, we got to get it into this format. And that is a different general equation altogether. And you have to complete the square in order to get it into that format. Once you complete the square, then you can figure out things like focus. Let's, before we leave that, let me talk about that. If I'm dealing with a vertical, the general equation is, oops, excuse me, there's no A. It's actually x minus h squared plus k. Excuse me. This is what you should have learned. Is that what you learned? Where k and h are the coordinates of the vertex.
Oh, yeah. And then you make k the opposite?
Well, if I had a vertex that is at 0, 0, like that, then k is 0, h is 0, and you end up with what you gave me originally. But this is only good for parabolas whose vertex is at the origin. If I had a parabola that was not at the origin, let's say I had a parabola like this, and this was point 1 and that was point 3, then the equation of this parabola, the general equation, is going to be, well, that's 2, so it's x minus 2 quantity squared, and it's y minus whatever the vertical thing is on that. I don't know what it is because we didn't define the equation. But when the vertex is not at the origin, you have to incorporate the h and the k. Do you have any problems that have that? And this is where you might have to complete the square in order to get your equation into this format. And that's the difficulty. In other words, when you are not at the origin, it's significantly more difficult to figure out where the focus is. The directrix, the line of symmetry is easy. You know, it's halfway in between. So the line of symmetry is x equal 2 in my example. But since I didn't tell you what the function was, we can't figure out what k is.
Okay, I have one that's like, write a quadratic function in any form given the following information.
Go ahead. Let's do it.
Vertex is -2, 4 through the point -1, 1.
Hold it. What was the second thing called?
Through the point -1, 1.
So it goes through that point?
Yeah. And then it says the X-intercepts are -3, 0, 7, 0, and they go through the point 1, 1.
What goes through the point 1, 1?
The X-intercepts.
Yeah, it doesn't make any sense. But let's figure out what we're dealing with here. First of all, let's deal with the X-intercepts. There's -3, there's 7. In fact, -3, 0, 7, 0. Okay, where's the vertex? -2, 4. Okay, so the vertex is right there. -2, 4. What were your X-intercepts? Read them to me again.
negative 3 comma 0 and 7 comma 0.
Do you see why the vertex can't be there? In other words, the vertex has to be halfway between your two intercepts. The vertex has to be at 2 comma 4, not negative 2. Is that possible? Could you have copied it wrong?
This is what she printed out, so...
Well, there's no way the vertex can be at minus 2, and you'll see why. Because the vertex is always symmetrical with respect to the x-intercepts. In other words, if I want the line of symmetry, it has to be halfway in between the x-intercepts. Well, halfway between minus 3 and 7 is 5, so I got to be 5 units to the right of minus 3 and 5 units to the left of 7. That's 2.
Okay, yeah, that makes sense.
Okay, so that would have to be 2. And they're saying the vertex is 2 comma 4. Well, your printout's saying it's minus 2, but there's no way it can be minus 2. Because it has to be halfway in between your x-intercepts.
Okay.
Okay. Now, it goes through the point minus 1 comma 1. Well, that point we'll call right there. All that means is that whatever equation we come up with for this, those 2 points have to satisfy that equation. In other words, whatever it is, y equal x squared, or whatever, those 2 points, that has to be the x point, that's the y point, and it has to still be an equation. Okay? So, let's see if we can figure out what it is. First of all, the standard format is y equals sum a times x minus h squared plus k. That is the standard format of a vertical parabola where h and k are the vertex.
Okay.
Okay? So we know that y equals a times x minus 2, the x-coordinate of the vertex, squared, plus 4, the y-coordinate of the vertex. You with me so far?
Yeah.
Now, because we know it goes through that point, minus 1 comma 1, that is going to allow me to solve for a, because I'm going to plug in 1 for y, and I'm going to plug in minus 1 for x. And then I won't have right now I got 3 variables, and I don't know what any of them are. I don't know what y is, I don't know what a is, I don't know what x is. But if it tells me that I go through the point minus 1 comma 1, then that's telling me that y has to be 1 whenever x is minus 1. With me?
Yeah.
So if I do the algebra here, what's minus 1 minus 2?
2.
No. Minus 1 minus 2 is minus 3. Square it.
9.
Solve for a. You get 9a equals minus 3. A equals minus 1/3. Okay? Once we've solved for a, now we know what the equation of this parabola is. Our answer should have a y and an x in it. And it's going to be minus 1/3 x minus 2 squared plus 4. There's our answer. Remember, your answer always has an X and a Y in it, and your goal is to solve for A, basically. And you do it with the information they gave you that it goes through that point. In other words, by giving us the vertex, we were able to figure out what H and K. When you first look at this equation, there's 5 unknowns. There's Y, A, X, H, and K. Well, the moment they give us the vertex, we know what H and K are. And then when they tell us that it goes through this point, we can substitute Y and X for that point and solve for A. And once we solve for A, H, and K, we have the exact equation for that parabola, which is what I have circled at the top.
So then when you did the equation where to get 3?
To get minus 1/3?
Yeah.
So all I did was solve the equation from this point. I only have one variable there. That's a straightforward equation to solve. Let's go through it. Okay. First of all, 1 is equal to A minus 1 minus 2. This is the subtraction sign. Turn all subtraction problems into addition problems and change the sign of what's being subtracted. So now we have minus 1 plus a minus 2. That's a minus 3. We're going to square it, add 4. Now I have 1 equals 9A plus 4. I'm going to subtract 4 from both sides. 1 minus 4 is minus 3 equals 9A. A equals minus 3/9, which is the same as minus 1/3.
Oh, okay. I just didn't know where you got the 3 because I didn't realize that you subtracted the 4 from over there.
Right. In other words, we're trying to solve for A. Once we get to the top line here, we have everything we need to solve for A. There's only one variable. Always know that when you have one variable and one equation, you're going to be able to solve for that variable. If you have 2 variables, you need 2 equations. You can't solve for either variable when you have one equation and 2 variables. So it's all about narrowing it down. But the critical part of this problem was the incorrect data they gave you. There's no way the vertex could be at minus 2, 4, and the X-intercepts could be these 2 intercepts. Because the line of symmetry has to go exactly in between your X-intercepts.
Okay.
In other words, if I tell you, hold on. If I tell you I have a parabola and the X-intercepts are minus 2 and plus 2 and plus 6, well, there's only one place for the vertex. What's the X-coordinate of the vertex?
3, 0.
4.
4. 4,
I
0.
don't know what it is. It's 4, Y. Because I don't know what that is because I didn't give you the equation of the parabola. If I would have said that that is y equal x squared minus 4x plus 10, well, now I can plug in 4 and tell you what the y-coordinate of the vertex is. But without giving you the equation, I can't tell what the y-coordinate is. But I always know the x-coordinate is exactly halfway between the x-intercepts, regardless of whether I know the equation or not.
So then the second one, the vertex and the x-intercept equations weren't connected. They're like 2 different things. So the second part of this is saying that like the x-intercepts are -3, 0, 7, 0, and go through point 1, -1.
Ah, that's why. There were two separate problems.
Yeah.
All right. So the first problem was a vertex of -2, 4 going through the point -1, 1. Right?
Yeah. Yes.
All right. Let's do that problem first. They're not the same problems, as you said. In other words, that's enough information to figure out the equation of this parabola. Give me the general equation of a parabola.
Y equals a parenthesis x minus h parenthesis squared plus k.
All right. What do we know at this point?
We know what h and k are.
Okay. So let's put those in.
So y equals a parenthesis x minus 2.
Hold on. H is -2. Don't drop negative signs. When you have two negative signs, it turns into a plus.
Okay.
Okay? If x coordinate was +2, then it would look like this. But if it's -2, it's got to have the different sign.
Okay.
Okay? K is +4. So that's the equation of our parabola. We know everything but A. So let's substitute the point that it tells us it goes through, and we'll be able to solve for A. Then we'll have the exact equation of this parabola. So how do I solve for A?
Subtract 4.
Not yet. We got to substitute. In other words, I've got an equation here that has 3 variables. I can't even begin to solve that until I fill in 2 of the variables. What's y and what's x?
Y is 1, and x is...
In other words, if this parabola goes through this point, then I can substitute 1 for y and -1 for x.
Okay.
Always. And that includes any equation, not just parabolas. In other words, it includes circles and everything else. Okay, help me solve this for A. First of all, get rid of the parentheses and square it. What's -1 plus 2?
1.
So I have 1 equals just A, because 1 squared is 1, plus 4. So A equals -3, 1 minus 4. So what is the exact equation of this parabola?
Y equals -3, parenthesis, x minus 2, x plus 2, parenthesis, plus 4.
You gotta always square that. In other words, you need one of the variables to be squared. The x is usually the variable that's squared if you're dealing with vertical parabolas. If you're dealing with horizontal parabolas, then it's x equal y squared. Okay? And the very first question you had was talking about focuses and directrix, which means you're talking about parabolas that are conic sections. in addition to being just quadratics. Okay? So that's where the 4C comes in. In other words, it's a bit of an oddity in mathematics that when you're first introduced to parabolas, you get this as the standard equation, right?
Right.
But when you get into conic sections, that equation, you get rid of the A, and it becomes this. And the reason they change it is so that you know exactly the distance to the focus is C. Whereas some school districts will say A is equal to 1 over 4C. And so even, not all school districts give you this format. Some stay with the original. But they also tell you that A is equal to 1 over 4C, so it allows you to calculate the focus. Personally, I kind of like staying with the original formula, but most school systems do go to this 4C format. It's important to realize that it's the same. They're no different. It's just a different format. It's a format that gives you the focus immediately. When you know the equation of the parabola, you can figure out the focus by whatever the coefficient on the y is. Okay, so this is the answer to the first part. And then you had a second part that was really a totally different question. And the second part said that you have a parabola that goes through these 2 points. These are the X-intercepts. And what point did this parabola go through? I think it was the opposite. It was 1 comma minus 1. Is that right? Okay. So starting with our standard format. Now, there's another format that is the X-intercept format. Have you been taught that? That format is this. X minus P and X minus Q.
Yeah.
P and Q are the X-intercepts. So, given the fact that they've given us the X-intercepts, it makes more sense to use this formula. Well, I don't know what A is yet, but I know what one X-intercept is, and I know what the other X-intercept is. You see how I get those two?
Yeah.
Okay. Now, using this point, how am I going to calculate A?
You're going to plug in 1 for each of those.
Tell me exactly what to write.
Y equals A.
This is an X and a Y coordinate.
Negative 1. Negative 1 equals A, parenthesis 1 plus 3, parenthesis 1 minus 7, parenthesis.
Okay. And notice that we have an equation that has only one variable. We're going to be able to solve for A. So that's equal to 4 times minus 6 is minus 24A equals minus 1. So A is equal to positive 1/24, which means the equation that they seek is this one. In X-Intercept format. Now, if they want that in any other format, we can just multiply it out. In other words, if they want it in standard format, FOIL those two binomials and multiply the whole thing by 1/24, and you'll have it in standard format.
Okay.
But given that they gave you the X-intercepts, probably makes sense to give the answer in X-intercept format. And again, the only thing you have to solve for is A. And you solve for A by taking the point that they told you and plugging it in for X and Y.
Okay.
Okay. We got about 5 minutes. Do you have anything else that we can cover in that period of time?
Hold on real fast. Let me look at my...
It's odd that they gave you a question regarding focus and directrix, and then all the other questions were more quadratic parabolas rather than conic section parabolas. In other words, when you originally learned quadratics and parabolas, they didn't teach you anything about focus or directrix or any of that, right? That was back in Algebra 1.
Right.
It's only in Algebra 2, when you start learning about conic sections, that they teach you that a parabola is also a conic section. And it has this different format and all these other things associated with it, like a focus and a directrix. So, have you had ellipses or hyperbolas yet?
No.
Okay. So the only conic section you've had is parabolas.
Right.
Which is actually unfortunate because they're the toughest one. Ellipses are actually easier than parabolas, and so probably are hyperbolas. But the reason parabolas are so tough is because they switch the format on you. They go from a vertex format to a parabola format. And everybody has a hard time adjusting. In other words, the vertex format is this. But the parabola format, always think of it as it has the 4c in front of the variable that's not being squared. So that's where the 4c goes, in front of the y, not the x. And you lose the a. And I think that k actually goes here. In other words, if you use this format for your parabola, you will know where the focus is. And you'll also know where the directrix is. And you'll still know where the vertex is.
Okay.
Okay? The only difference, you can see that A has to equal 1 over 4c. In other words, if I take this equation up here and subtract k from both sides, I get my y minus k, and then A has to equal 1 over 4c. So even if you were in a school system that stayed with that format there, the only thing you'd have to do to figure out the focus is do that arithmetic right there, which I kind of like better myself, rather than giving you a whole new format, which is what most school systems do. And then, of course, you don't have to do this. You just figure out what C is based on whatever your equation is. If I said to you, y equal 2x squared, what's c equal to?
2? Wait.
No, if a is equal to 1 over 4c, then I get 4c is equal to 1 over a, so I get c is equal to 1 over 4a. Well, in this case, a is 2, so c would be 1/8.
Okay.
Okay, so it's probably good to know both ways and both formats. It's not going to hurt you as long as it doesn't confuse you. As long as you know that this is the same as this, it's just that when we're in this format here, we come up with exactly what, it's easier to come up with C. In other words, when I gave you y equal 2x squared, if I want to put it in this format right here to figure out what C is, well, I can tell there's no coefficient here, so I got to divide both sides by 2. So I get 1/2 y equal x squared. Well, now I know that 4c has to equal 1/2, right?
Right.
So c equals 1/8. Same thing.
Okay.
All right. Sierra, that is the way an online session works. I have been recording this, and I will send you a link. Let me get your email address. Hold on. Yeah. What is your email address, Sierra?
CIERRA MART98@gmail.com.
Yeah. In fact, I remember you gave that to me once. I just didn't have a piece of paper in front of me. How would you like to pay for these sessions? Is your parents going to pay, or?
Yes.
Are they going to use PayPal, or would they like to send me a check, or?
Probably PayPal.
PayPal is the easiest way to do it. Let me give you a different website, however, because the easiest way to pay PayPal, I might have given this to you already, is to use this website, not Algebra to Calculus. They're both my websites. It's just that the PayPal option is much better here. And let me show you exactly how you would do it on Digital Math Tutor. Okay? Go to the front page of Digital Math Tutor. Go down to where it says Buy Now. Click on it. And it's going to immediately bring up the PayPal window. Well, in this case, it's $32 for this session. Okay, so enter 32, and then your mom or dad will have to put in the PayPal password and authorize it. But it's really smooth here. They only have to put in the amount, and then, of course, everything they put in over here I don't see. But it authorizes the payment.
Okay.
Okay? So I will let you do that. I will send you a link tomorrow morning to where you can see a recording of this session, and I will let you go from there. Actually, why don't you give me the email of whichever parent is going to pay? That way I can send them an invoice.
Okay. It's SEAGAYZER@msn.com.
And what's that person's name?
Sherry Angsberg.
Sherry?
Yeah, Sheri.
What's the last name again?
Engsberg.
Okay, let me make sure I got that email. You said SEA as in C?
Yes.
GAYZER. Z as in zebra?
Yes.
At msn.com.
Correct.
Okay, I got all the information I need, and I will leave everything from this point up to you. If you want to schedule another session, you know how to do it now. You can also schedule sessions on that digital math tutor. You can do everything on that you can do on Algebra to calculustutor.com.
Okay.
Okay, so it might just be easier for you to use the digital math tutor. I'm kind of trying to switch over all my online tutoring to digital math tutor.
Oh, okay.
So, okay. Sierra, you have a good evening. I hope I've been helpful.
Okay, thank you very much.
You're welcome.